memory units, and I know I gave a brief discussion on this, but we can now talk about them in detail. Memory unit is the amount of data that can be stored in the storage unit. This storage capacity is expressed in terms of bytes. The following table explains the memory storage units. The smallest storage unit is called bit. I already explained that. It is stored in one cell from your storage device. A binary digit is either logic 0 or 1, representing a passive or an active state of a component in an electronic circuit. So I said that you might want to store and say a number like number 8 in a computer, or number 7, or alphabet A, F, K. All of these are stored as 1 byte. The simplest one to start with is we represent 8 as 1000. 8 is actually stored in binary numbers as 1000, and we are saying that the logic, the numbers in computer systems are stored as either a series of ones and zeros. So that simply means that a number or binary number can either be a 1 or a 0. So the idea is that you can store 8 as 000, but for it to become 1 byte, we normally add zeros in the beginning or to the left, so that it will be represented as 000, then 1000. So that is a binary. It has 8 bits, and therefore we are saying that this 1 bit is either 1 or a 0, but then all of them combined will make 1 byte. And a nibble is a half of a byte, or 4 bits. We rarely use this one, I should say that, but it's just good for you to know that if you hear someone referring to nibble, then you know that they're talking about 4 bits in comparison to the most common one that's called bytes. A computer word like a byte is a group of fixed number of bits processed as a unit. It varies from computer to computer, but is fixed for each computer. In nowadays computers, you'll hear there are computers that are classified as a 2-bit computer or 2-bit system or 64-bit system. So the 64-bit system and the 2-bit computer system are said to have a one word of 64 bits and or the 2-bit, depending on which system you're talking about. So you're saying that those computers will get a chunk of bits from memory or for processing and process them as 64 bits or that are 2 bits, depending on either of the two systems. So we are simply saying is that a computer word is a group of fixed number of bits that can be processed as a unit. You are going to find some computers are going to be the 2-bit or 64-bit. And I can tell you that the bigger the chunk a computer can process, the faster that computer is. So you find that 64-bit computers are way much faster than the 2-bit computers. This is the other classification that I mentioned earlier, that 1 kilobit is equal to 1024 bytes, then 1 megabyte is equal to 1024 kilobytes. Now, if you want to express this one in terms of byte, you would say 1024 times 1024. This will give you the size of 1 megabyte in terms of bytes. Then 1 gigabyte is 1024 megabytes, which is equivalent to 1024 times 1024 times 1024 bytes. So you can see, if you estimate this one to be in thousands, that is when it becomes 10 to the power 9. But they say we don't use this phrase. These are just for estimation. So we know that 2 to the power 10 is equals to 1024. So the question is 2 to the power, so for you to make 1 megabyte, you definitely require 2 to the power 10 times 2 to the power 10. And if you remember your mathematics, when you have multiplication with the same base, you'd say 2 to the power 10 plus 10. This would be equivalent to 2 to the power 20. For a gigabyte, these are now bytes. So if for the gigabyte, you would say this would become 2 to the power 30 bytes. And lastly, there is a terabyte. I know most of the hard disk nowadays come as a 1 terabyte, and there is 1 petabyte. Petabyte is barely used, but is used by data centers and other heavy or data usage as computer centers.